Good morning, students. This is KG Misra. I'm here with the new chapter of class 9th, that is force and laws of motion. Okay. In order to start this chapter, let us see some activities. Okay. You can see this is a ball. What is the shape of this ball? Spherical. Okay, correct. Now, see what I'm doing. I'm just pressing this ball, and what you find? Is it still spherical? No. That means what has changed? Shape. Okay, the shape of the ball has changed. Because why it has changed? Because I applied the force. Okay, so due to application of force, the shape of the ball changes. Okay, now what do you find? What has changed? It is shape. So I should write here what has changed. Shape. Now you can see this is a rubber band. You can see its length. Okay, now see what happens. I'm going to pull it. What do you find? There is some change in the rubber band. Is there any change? What has changed? Oh yes, length. That means size. Size of the rubber band has changed once the force is applied. So what has changed? Size. Okay. Now see, this ball is going to be in motion. Just see it. It is at rest first. Okay, you can see it is at rest. It is at rest. Now what I am going to do? I am going to apply force on it. Okay, just see what happens. I am applying force. What you see? What happened? Started moving. Again you want to see? Okay. See, this ball is at rest. Okay, I am going to apply force on it. See what will happen. Okay, it came into motion. Okay, so what has changed? State of rest to motion. It has come from state of rest to motion. Okay. Next, see, this ball is in it is in motion. Now I'm going to put my hand over it. What do you find? It comes to rest. You want to see it again? See, again it is in motion and I have kept my hand over here. What do you found? It came into rest. Again you want to see? See, it is in motion and I'm going to put my hand. What do you find? Stops. So what you found? You found that moving body stops. Okay. Next, see very carefully. Okay. See, it is moving in this direction. I put my hand on where it has gone. Started moving in that direction. You can see again. It is moving in this direction. I've kept my hand. And what you found? The direction of the motion is changed. See? What you found? The direction of motion has changed. Again you want to see? See. So what you found? The direction of motion is changed when I'm going to apply the force. Okay? So direction of motion. Okay? And next, see what else changes. See, it is moving. Once again, I am going to apply force. So what will happen? Move faster. See, have you seen? It is moving. I am applying force, and you see, becomes faster. Again, you see, I am applying force, and it becomes slower. See, now see, it becomes slower. See. See, it will become slower and then stops later on, obviously. So it has become slower. Okay. It is going fast and then see it has become slower. It's going fast and then it is slower. See, it is going fast and then sorry, I've completely stopped this. Just a second. Coming and then see it is slowed. Okay. So changes the speed or velocity. Velocity. Okay. So what changes we have observed? We have observed that when we apply force, what happens? Shape is changed, size can be changed, may be changed. Okay. State of rest from body can come from state of rest to motion, or a moving body may stop. Okay. Direction of motion of a body may change. Okay. It may change the speed of a body, speed or velocity of a body. Okay. So these are the changes which force are capable of. Okay. That's what we have seen. So now you put the heading force. Always you have written that force is a push or pull, but we are not going to write that definition. Okay. We are going to write a definition which will help you as a definition, as well as it will help you in writing the effects of force. Okay. So let us start writing. Okay. The physical quantity which may change shape of a body, comma, size of a body, comma, state of rest to motion, comma, bring moving body to rest, comma, direction of motion, comma, rather you write, instead of comma you write, and speed oblique velocity of the body is called force. Got it? So what is force? It's a physical quantity because it can be measured. No, what type of physical quantity? Which may change the shape of a body. Why I'm saying may? Because see, if you are applying lesser force, it's not changing its shape. No, so it may change. Okay, it may not change also. So it may change shape, size, state of state of rest to motion of a body. Then moving body, it can stop it. Okay, and it may change the direction of motion. It may change the speed and velocity of a body. That means it may make it move faster, or it may reduce its speed or velocity. Okay. So this type of physical quantity is called force. Full stop. It is a vector quantity. And denoted by capital F oblique small f. Okay. Force you can denote by capital F or small f, comma, and its SI unit is kg meter per second square or Newton. Okay, that we denote by capital N. Okay, so these are the denotions and SI units of force. Okay. See, forces are of two types. First, balanced force. Okay. And second is unbalanced forces. Okay. First is balanced. Its single L is there. And unbalanced. Okay. Okay. So balanced forces and unbalanced forces. Now what are balanced forces? I think you have studied in class 8th also, but here also I will like to tell you. Suppose a body is there. Okay, this is a body, and on this body, a force is acting from this side. Suppose F1 is acting. Okay, a force is acting from this side, let it be F2 is acting. Okay. A force is acting from this side, let it be F3 is acting. And a force is acting from this side, that is F4 is acting. Okay. These are the forces acting on this body. Now, if you find that sum of F1 equal to F2 and F3 equal to F4, okay, then what will happen? Then net, then what will happen? F1 will cancel F2, okay, it will balance F2, they will cancel F2, okay, so these will cancel each other, and this F3 will cancel F4, or you can say F3 will cancel the effects of F4, okay. So in this case, what we can say? Net force acting on the body is 0. Okay, net force acting on the body is 0. Okay, so this is case of balanced forces. When lots of number of forces, so write the definition of balanced forces. Okay, I think you have understood from here. So start writing. When a number of forces are acting on a body, when a number of forces are acting on a body such that the net force acting on the body is 0, such that the net force acting on the body is 0, comma, then those forces are called balanced forces. Then those forces are called balanced forces. Okay. Clear? What are unbalanced forces? Let's see. We can discuss. Okay. See, for I'm going to explain you unbalanced forces. Okay. Suppose this is a body. Okay. And a single force is acting on this. Suppose this F1 is acting. So obviously there is no other force to oppose this. So what is the net force acting on the body? It is F1 only. So it is not 0. So this force is called unbalanced force. Now suppose here F2 force is also acting, and such that F1 is greater than F2. Then what will happen? Then F1 minus F2 will be not equal to 0. Okay. So F1 minus F2 will not equal to 0. So F2 will not able to balance F1 completely. So what will happen? Suppose F1 is, I'm saying 5 Newton. Okay. And F2 is suppose 3 Newton. So what you find? This sum is equals, this difference is how much? That is 2 Newton. That means F2, which is 3 Newton, will able to balance only 3 Newton out of F1. So when it is able to balance only 3 Newton out of F1, then how much force is left? It is 2 Newton in that direction. Okay. And that 2 Newton is called net force acting on the body. Okay. Or you can say that is called unbalanced force acting on the body. Clear? So now put the heading unbalanced force is and start writing. The forces which are acting on a body, such that net force acting on the body is non-zero, then those forces are called unbalanced forces. Okay. Those forces are called unbalanced forces. So here 2 Newton is what? It is unbalanced. 3 Newton out of this has been balanced by this 3 Newton. So what is left? That is, so net force is called unbalanced force. Okay. Clear? So net force is called unbalanced. Okay. Our next topic is inertia. Okay. Now what is inertia? You write first, then I will explain, okay? Start writing. The tendency of body to resist, resist, resist the change in its state of motion or rest or direction of motion or rest or its direction of motion is called inertia. Okay, so what is inertia? It is tendency of body. Which type of tendency? To oppose, to resist. What to resist? The change. Change in what? Change in state of motion or state of rest or in the direction of motion. Suppose that means if a body is suppose moving with the speed of 550 meter per second, then it tries to continue to move in the same direction with the same speed. Okay, unless someone is not going to force it. Okay, and if you will try to force it, then you will try to oppose it. Okay, so you have to counter that position in order to stop it or increase its speed. And if a body is at rest, then it remains at rest. You might have seen suppose the duster lying on the teacher desk of your school. When you reach next day, again you find the duster is lying over there only. It has not moved by itself. Why? Because it tries to resist the change. Okay. Now a body is moving in a particular direction, tries to move in the same direction, unless you are going to force it to change its direction. Okay, because it don't like to change at all. So in simple words, we can say it doesn't like the change. Okay, see here, this is the, you can see this is the pencil box. Okay, I'm just going to apply some force. I'm applying some force. Still it is not moving. Okay, and I'm going to increase that force. Okay, now it is just moved. Okay, I'm going to even increase the force. Now it is moving. So that means up to certain extent it is able to oppose the force applied by me. And when the force applied by me exceeds its opposition, only then the body moves. Okay. So why it is opposing? Yes, obviously because of its inertia of rest, that we call as inertia of rest. Because it was in rest, so it tries to remain at rest. Okay. Unless you apply adequate amount of force to it. Okay. Now, in the same way, when a body is in motion, no, then it tries to remain in motion. See, this is in motion and I'm trying to put my finger, but then also what you find? Due to my finger there was application of force, then also it is moving, it has gone slow down, but still it is moving. So, but if I want to stop it, then what I have to do? I have to apply more force, okay, to stop it. So adequate amount of force has to be applied, otherwise it will oppose it and it will continue, maybe with the decreased speed, but it will continue to move. Okay, and it tries to move in the same direction. See, it is moving in the same direction. See, it is moving in the same direction. But when I apply force, what happens? Only then I can change the direction. Otherwise, its direction will not be changed. So that is inertia. Now the question arises, how we can understand inertia? Means what factor decides how much inertia a body will have? So next you can write, mass is the measure of inertia. Okay, that means mass is the measurement of inertia. If a body has got more mass, then it will have more inertia. If a body has got less mass, it will have less inertia. And that's why when you are trying to push, see here. Okay, I'm going to apply some force on this. Okay, what you found? It started moving. Now same force I'm going to apply to this. What you found? Is it moving? No. Why? Why it is not moving and this started moving? Again you want to see? Okay. See, I'm going to apply some force. What if one started moving? Now what about this? See, not moving at all. That why it is like that? Because see, it is very light. It has less mass. Okay, it has less mass. Whereas this has more mass. So because pencils and other things are kept inside it. So as it has less mass, so it has less inertia. So it will oppose less. And pencil box has got more mass. So it has more inertia. So it will oppose more. Got it? Clear? Okay. So mass is the measurement of inertia. The body having more mass has more inertia. So it is very difficult to change their state of motion. That's why you will find, suppose you might have seen the kids, they are cycling. A kid is coming cycling towards you, okay, and you are standing in the road, and the suppose kid is cycling with the speed of 5 meters per second only, and comes and hit you. What will happen? Nothing much. No, it may happen that kid may fall. So again he will lift him, okay, or put him onto the bicycle, and again he will give a nice smile and allow him go. But suppose with the same speed a truck is coming towards you and you are standing on the road, what will happen? Is it like that? Nothing will happen to you? No. It may hurt you a lot. Okay. Why? What is the difference? Both were moving the same speed. Then where is the difference? Yes, because the truck has got more mass, so it has more inertia, so it will try to remain in motion. Okay, it will have more inertia, so it will try to remain in motion for a greater extent. Okay, so whatever obstacle it is going to face due to you, it will not stop due to that, but it will try to remove the obstacle from the way. So it will drag you or whoever is standing. Okay, so that means truck has got more inertia. Okay. Now inertia is divided into three parts. First, inertia of rest. Okay. Note down this. Noted. Write the definition. When a body is at rest, it tries to remain at rest until and unless some external force is applied on it. Full stop. For example, okay, you can see this coin, it is 2 rupee coin. You can see 2 is written over here, and it is placed over this, and this has been placed over this glass. Okay, now I will be pulling this. So what do you expect? This coin should go with this cardboard. Okay, but let's see what happens. As I have pulled this, where the coin has gone? It has gone inside the glass. Why? Because of it was at rest. So due to inertia of rest, it tries to remain at rest, and that's why it has fallen over there only. Because base was removed, so it has fallen inside the glass. It has never moved with this cardboard. Again, you want to see? I will show you again. See, this is the coin. Okay. See, I have removed this. Okay, and the coin has fallen inside it due to inertia of rest. So this is one example. Okay. And about the other examples, you can think of it and write it. Okay, that's I'm leaving on you, and later on I can explain to you, or I can give you more examples. Next is inertia of motion. Inertia of motion. Note it down. Heading. Written. Okay, write the statement. It states that a body in uniform motion will try to remain in uniform motion until and unless some external force is applied on it. body is, for example, you can see when you switch off the fan, what happens? Does the fan stops immediately? Yes? No. Why it continues to move? Because of inertia of motion. I can give you one more example of inertia of motion. Okay. And inertia of rest both. Okay. Suppose you are traveling in a bus. Okay. You are standing in a bus, suppose. And bus is at rest. Okay. And driver starts the bus. As soon as bus starts moving, what do you feel? Do you remember? The moment the bus starts, you fall in the backward direction. Why? See, because your lower part of the body, that is your feet, is in direct contact with the bus. Okay. Whereas your upper part, it is not in contact with the bus. So as soon as the bus starts moving, your whole body was initially at rest. As soon as bus starts moving, your lower part comes in motion, or your feet comes in motion with the bus, and it moves ahead. But your upper part of the body remains there only. So as the feet will go ahead, what will happen? See, you will fall in the backward direction. Okay. And that's why you fall in the backward direction, because of inertia of rest of your upper body part. Okay. Now second one, inertia of motion. Suppose you are standing on a bus and bus is moving and passing, okay, through very nice sceneries around, okay, all, okay, natural beauty is there all around everywhere. And suddenly your one of classmates bus stop comes. So what will happen? Travel will stop the bus, apply the brake. As the brakes are applied, you try to fall in the forward direction. Why? The reason is that because your feet is in direct contact with the bus, so it comes to rest with the bus. But what about your body? It was moving in the forward direction. So due to inertia of motion, it continues to move. Your feet came into rest, but your upper body part continues to move. And that's why you fall in the forward direction. That is the example of inertia of motion. Okay. Next is inertia of direction. Okay. So first write this, then I will explain you. Okay. See, start writing. It states that when a body is moving in a particular direction, then it tries to continue to move in the same direction until and unless some external force is applied on it. Full stop. See, what does it say? It says that if a body is moving in a particular direction, then it will continue to move unless you are going to apply some force on it. Okay. You will apply some force, obviously it will change its direction. Okay. Like see, a football is kicked, okay, from the corner in a football match. It tries to go in the same direction unless someone comes and do the heading part, no, like this. Okay. When head is done, then what happens? This ball changes the direction and goes into the goal. So when the direction is changed, only when the external force is applied. Otherwise, it will continue to the same path, same direction, due to inertia of direction. I will give you one very nice example. I think many of you have traveled in the buses, okay, cars and other. Not many, but all of you, I think. Okay. See, when you are traveling in a vehicle, what happens? Suppose vehicle is going straight away. Now, so your body is in motion in the forward direction. Now what happens? This was that direction of motion initially. But as soon as the bus takes left turn like this, what happens? You bend like this. Why you bend like this? Is it your habit to bend towards your right while the bus is taking turn towards left? No. Because it is your right now, but initially it was your front. In which that it was the direction in which you was moving with the bus, and now it has become your right, and that's why your body still tries to go in the same direction, and that's why you bend. So you are bending because of inertia of direction. Now, if the right turn is taken, then that direction has become, the front direction has become your left direction. And that's why you bend towards left. When bus takes the right turn, you bend towards left. When bus takes left turn, then you bend towards your right. Okay. This bending occurs because of inertia of direction. Okay. Next heading is Newton's first law of motion. See, this law is also called law of inertia. Okay. It is actually only qualitative study of force. Okay. Which talks about the effect of force only. It doesn't give any quantitative measure of force. Means it is not going to give us any formula which will help us to find the value or magnitude. It gives only effects, talks only effect of force. Okay. Now, what does it states? At the statement, it states that a body at rest or in uniform motion in a particular direction will remain in the same state until and unless some external unbalanced force is applied on it. Full stop. Same thing, that inertia part, no? If a body is at rest, it will remain at rest unless you are going to apply an unbalanced force on it. Okay. If a body is in uniform motion in a particular direction, it will remain moving the same way unless you apply some unbalanced external force. Neither it will change the direction, nor it will change its speed, or neither it will come to rest. Okay. That's all this first law states. Okay. Now, let's go to the example of this. Okay. So, first example we can say, no, that's all the examples of inertia we can use. Okay. For example, suppose you might have seen, no, people, what they used to do. They used to take the cloth and they used to beat it by a stick. Okay. Like woolen clothes generally, blankets and the things. They used to beat by stick. And when they beat by a stick, what happens? The dust comes out. Why? Because see, when the stick is falling on certain area of a blanket, no, then it gives some force to that. And due to that, that part of the blanket moves, suddenly moves. As suddenly it moves, what happens? The dust particles which are there connected with that part of the blanket, they are at rest. So, due to inertia of rest, they will remain at rest. So, they get separated. See, this is the blanket, and suppose this is the dust particle. Okay. As the blanket is hit, what happens? It will move, and this will remain here only. So, what will happen? This will fall. Okay. So, in this way, this dust particles get separated due to inertia of rest. Okay. You might have seen people wave this bed sheets like this, no? For separating the dust particles. Why? Because see, once they are moving in the upward direction, the dust particles are also moving in the upward direction. But suddenly what we do? We used to pull the bed sheet in downward direction. So what happens? The direction of motion of the bed sheet has changed down to downward from upward. Okay. But what about the dust particle? Due to inertia of direction, it tries to go up. So it gets separated from the bed sheet. Okay. So these are the examples of Newton's first law, because it is basically all about inertia. Okay. Thank you, children. In the next part of the video, I will come with the Newton's second law and the other topics of this chapter. Till then, keep on studying and take care.